to Defy Robotics. I'm Ben Defy.
And my name's Jack Defy.
And this is our project, Untethered Firefly Synchronization. So, this is an engineering project as an extension project of our project last year. So, for our project last year, we decided to model firefly synchronization. In the wild, there are certain species of fireflies, such as Photinus carolinus and Troptrix malachi, that'll actually synchronize their blink. So, last year we modeled this, but this year we decided to create practical applications from it.
Now, I'd like to jump to the end real quick and talk about our final products that we developed. First, we have Firefly Hat version 1. Now, this device, as you can see here, is with the primary goal of synchronizing the actions of individuals. So if you imagine trying to take a group jump photo, everyone has their own way of jumping, and it can be quite difficult to synchronize. But people are inherently a lot better at synchronizing their own action to some sort of metronome, say the constant blinking of a light. Now, these hats will synchronize their own blinking, so that everyone wearing them will have this synchronized flash on their head. Then each individual synchronizes their own jump to that blink, and suddenly you can take a group jump photo a lot easier. The same method applies to a lot of things, so these hats achieve our design goal of allowing people to do synchronized things.
So then our second application is the Firefly Hat V2. So for this application, we had a new radio that allowed us to get distance measures. So using this, we decided to create different algorithms that would use these for practical applications. The main one that we did was the crowd sync algorithm, and what this does is, based on how far away you are from others in a group, you'll blink a different color. That way, if anyone gets lost, the entire group will know, and they can go over and find them. So, how we got to these different prototypes. So, the way that we did this was we started out with an extensive prototyping phase where we tried all sorts of different ways of synchronizing. So, we tried infrared, we tried visual light, we tried radio signals, and we tried even using phones to synchronize. We found that radio signals in the Firefly Hat V1 was the most effective by far.
So back to the Firefly Hat version 1, as I mentioned before. This initial prototype was, in a lot of ways, an extension of our previous work. In fact, it uses the same computer that we had in our board last year. And we also implement a very similar synchronization strategy as we developed. The key difference is that this is now wireless, using this radio frequency transceiver, and it has a much brighter visual given this large LED light array, which is encased in a paper lantern. Now, how we got from here to the Firefly Hat version 2 you see on my head. We went through, again, another prototyping process. First, where we went a lot smaller, and as we went through, we realized a few of our design criteria. Now, over here, you can see we had several design criteria for this process. First, they had to communicate wirelessly. We wanted to reduce power consumption. We wanted to simplify the construction on our end, have some measure of distance, have some measure of the number of neighbors, maximize wearability, visibility, and the simplicity for the end user. Now, through this, we came to Firefly Hat version 2. You can see here. Now, we initially set out to make it a lot smaller, and we came across this board called the Adafruit Feather. There's another version with a built-in radio, which critically adds a signal strength indicator, which we implemented for distance measure. In addition, we now have a full color spectrum RGBW light array that we custom soldered for this application, and we also have a new power source. Whereas before we had a very complex power source, now we have simply a single cell LiPo due to the switch from a 5 volt to 3.3 volt logic. In addition, we have this custom 3D printed housing, where we've advanced from a cardboard box through this design process to this clear 3D printed housing that acts as a light bulb for the device. It also has mounts for these straps, kind of like a bike helmet, and it has a mount for the antenna to hold it still.
So now, looking at improvements that we made on the software. To make the crowd sync algorithm happen, we had to make a number of different changes to allow the signal strength indicators to work correctly. So the first change was simply getting the signal strengths. Because when we do the synchronous blink, we can only actually receive 2 signals. We can receive one signal and then store another one in the buffer, but that's it. So if we have a swarm of more than 3 fireflies, we can't actually accurately get signal strengths. So to fix this, we had to create some sort of other blink of the radio that was between the synchronous blinks. So we had a hard-coded delay in each firefly that after the synchronous blink, it would then send out a radio signal for each of the other fireflies to receive and find the signal strength. Then, we found that the signal strength is actually very variable. So to fix this, we sent out bursts of 10 signals instead of single signals, and then did a simple averaging algorithm to then find a more accurate signal strength for each firefly. So, through these changes and the improvements in the case to reduce jiggling of the antenna and the hardware, we found that the standard deviation of the signal strength went down, and we found that the average signal strength was higher.
Now, in conclusion, we met our design goal of constructing and implementing a swarm of synchronous devices. We met this first with our Firefly Hat version 2, and later with Firefly Hat version 1, later with Firefly Hat version 2. Looking at next steps for this project, we're really excited about mounting these devices on drones with the application of drone tag. In addition, we want to host a larger field test in order to see how our algorithm works more with a larger quantity of fireflies and do a more conclusive data. Thank you, and see you next time
On Defy Robotics!